Hi and welcome back to another video on Sparky World. This one's for all the qualified electricians or apprentices looking to get ahead in the game. So, do you want to run your own electrical business? In Ireland, if you want to become a tester for a company, or if you want to open your own electrical contracting business, you wish to be the competent designated person who completes work and is responsible for signing off that work, then you need to be a qualified electrician, B, complete a course. That course is Electrical Testing and Verification of Electrical Installations, Ireland, City and Guilds 2407. When you finish your 4-year electrical apprenticeship, you can apply through your company or by yourself to one of the companies to deliver this course, to do this course. This course usually is for beginners and it takes a week to complete. And with this course completed, you can work for a company as a tester. You can be a one-man band business of your own, EICR or electrical installation condition reports as a freelancer for other businesses. Even if you don't intend to do any of this, it is a great qualification to have as an electrician and shows you understand what you're looking for and how to find faults. It is expensive, so if you work for a company already, ask them to put you through this course or at least give you a contribution towards it. At the end of the day, they all want better electricians. The reason for this video is for anybody who's a qualified electrician in Ireland and you want to complete this course with all of the relevant information in a couple of videos and explain all the tests that you're required to learn, complete, and know how to use them in the field. We are usually visual learners and we learn by doing, so it is easier to watch a video with most of the information you need and be able to reference that video whenever you need it in the future. That this is the boring part of the video and in the series that deals with getting started and what you need to know about the pre-tests and getting ready for testing in your exams. In the next video, we'll go through all of what the test entails. So what will you need? To do any electrical work in Ireland, and if you're not employed by a registered business, even if you're a qualified electrician with many years experience, you cannot carry out any restricted or controlled electrical works. All you can do is minor works, such as changing a socket or a light fixture. You cannot alter a circuit. To do this work, you have to either register your business with Safe Electric, and if you want to be a tester and certifier or a QC for this business, also you need to complete this course mentioned before. It can take quite some time to start your business and register with Safe Electric, but I will do the process of starting your own business to being a registered contractor and everything that entails in another video for those who are interested in learning about the process from start to finish. It is not what this video is about, however, this is about testing. So, when doing this course, everything you need will be provided, but I'll include things that you'll need after for your own business. When you start your own business and doing your own testing, you'll be required to have your own copy of the National Rules and Regulations. They are currently the NSAI National Rules for Electrical Installations, IS 10101 Edition 5. You'll have used this book in your apprenticeship. You'll be required to own certain test instruments to carry out for testing. They include an insulation resistance / continuity tester, an earth loop impedance tester, and an RCD tester. These have generally been replaced by the MFT or the multifunction tester, which can do all of the required tests on one instrument. These will be used when you are training to learn and become proficient with its use. Note, these are very expensive and it may be worth considering renting one as you start your business. Your multifunction tester also requires a calibration every year from the moment of purchase, as the tester must be in calibration date before you can submit any test readings or paperwork to Safe Electric. This usually costs around €100, which is a good bit, but they insist that this is done. Now, the company that you buy from will usually calibrate your new equipment when you buy it for the first time for no charge. Another handy piece of equipment to have would be a sensitive current clamp meter. This isn't usually included with your MFT, but usually you can get away without it, but the cost is worth it to get one. This device will allow you to fault find such as nuisance tripping RCDs by checking earth leakage currents and also check the system is not overloaded and nearly at the mains ESB fuse breaking capacity. That's usually 60 or 80 amps in Ireland. Now, 2 electric showers in one of these properties able to run at the same time would definitely overload the system. In that situation, you would need something that would prevent both showers coming on at the same time. It used to be easier to test old devices that came before RCDs, that is voltage operated earth leakage circuit breakers. You may come across these in older installations, though they're pretty rare these days. So, earth fault leakage current is when current from a live conductor leaks to earth. It is what the RCDs and RCBOs are made to detect. In a normal house, anything above 30 milliamps will trip that device. This will happen in a fault. However, with things such as laptops and tablets and smart TVs in our houses, devices naturally leak small amounts of current to earth, about 1 or 2 milliamps usually. If there are several socket circuits protected by one RCD, and there are many electronic devices plugged into them sockets, the earth leakage can add up. Once it comes close to 30, depending on the sensitivity of that device, then these can cause all of the circuits to switch off from the RCD tripping out. Water damage can also cause this. With a clamp meter, we can isolate the circuits and find the common cause of the tripping. A good piece of information to note is that in IS 10101, in section 531.3.2, page 262, accumulated leakage currents downstream shall not be more than 0.3 times the rated operating current of the RCD. In plain English, that means 9 milliamps should not be exceeded total of all the circuits on an RCD. Stick to this as a general rule. As technology becomes more advanced, new tests will be required in the future. These will require our MFT instruments to have more features and abilities, but also more information required for us to learn on how to complete these tests. This is not part of the current electrical test and verification course, so I will not go into detail on this as it's not required to learn for now. When we say we are doing testing, we need to know why. Testing and verifying circuits enables to see if any area of the installation is safe, dangerous, has a fault, or many faults. It can prevent things such as house fires, electrocutions, and death. There are different requirements for why we would test. For example, on an older installation, we could do a PIR, which is a periodic inspection report, also called an EICR. This will involve routine testing of an installation to see if it is safe. With this, we would then also fill out our test record sheets. Completing minor works such as moving a socket or a light to a different location would require a test of that circuit once completed. Though it is important to note that it is not required to complete paperwork for this. It is required to administer a completion certificate number 3, domestic house less than 50 kVA if the customer asks for one. New installations require testing of every circuit installed and every aspect of the installation required by the test record sheet, and a completion cert using forms 1 or 2 and or 3. New installations should not have any limitations listed, and every test should be carried out. For example, insulation resistant tests from line to neutral done in a pre-connection on circuits without delicate electronics, if this is possible. Let's start now with the process and step by step of doing the course and how to verify and test. Step 1 is always safety. It's simply the most important point to make. We may be sick of hearing about health and safety on sites where electricity is the most important thing and the reason why we do all this testing in the first place. So why not take care of your own life and make this the first step in any test sequence? Make sure to have locks and MCB locks and warning labels in your toolkit. Safe isolation, the lockout and tagout system of work. This is good practice and will ensure your safety and that of everyone else around you. This involves using MCB locks with padlocks and labelling. Only you will be able to energise that project. Even if it is a brand new installation where no connection is yet provided by the service provider, the ESP in our case, there may be alternative forms of generation, such as that of a petrol generator or solar photovoltaic systems, which is common in new builds. Even when not needed, do safety checks first. Repeating the same process time and time again will keep you safe. You should copy the link provided here into your browser or search for David Savory's channel on YouTube, and the video is entitled Safe Isolation Procedure. It really is a brilliant and comprehensive. You should definitely take the time to watch this. It goes over everything in perfect detail and explains it way better than I ever could. Once you are sure you are safe, you can move on to the next steps. All the relevant sections to deal with test and verification, including annexes, recommended results, and tables, are in Chapter 6 of IS 10101. As stated by the name of the video, the word verification is included in the course. As stated by NSAI rules for electrical installations, Part 6, Verification, Section 6.4, page 4A2, there are several statements that basically explain what verification means. Basically, this means before any testing occurs, there must be verification of new or existing installations that are in compliance with the rules stated in IS 101 are adhered to for safety. Also, in this section of verification, there is an important subheading labelled Inspection. Inspection is using all of your senses, especially using your sight. So, for example, if you see something wrong on a board, such as no compression glands, or if you can smell Burnt cables. I can see charred cables as well. This is using your senses. According to IS 10101 64.2.1, page 483, visual inspections shall precede testing and shall normally be done prior to energising the installation. Here there's a whole page of guiding pointers and reminders of what you should inspect for and check before you start physically testing, and why it's so vitally important will be explained shortly. For example, identification of neutral and protective conductors. This inspection of installation is part of your final day exams in the course. You'll be shown an example installation with many violations of the rules. You'll need to look over the installation, and from experience, using your IS 10101 book, you will write down all of the problems visible without testing and explain them in simple terms and what you do to rectify the situation as you see fit. This is challenging and it's timed, but you should be able to see the majority of the problems almost immediately. Do not panic and make sure you check over every single part of the installation so you don't miss anything. Remember, this part is hugely important also because it's to prevent you from being in the hot water later, even if you are not at fault. You don't want to put your name on anything or sign off on anything which does not meet the standards set out in IS 10101. Why take the risk when you can inspect and verify an installation is the standard before even testing? And when it's tested, it can be certified safe for DSO connection, for example. If you've seen an SWA cable enter the board without a gland properly installed, fixed cables with a single insulation protection, strip too far back enter the board like this, and even incorrect conductor colours, we notice installation, even before we test, is not safe or ready to be certified. YouTube is an amazing resource for us electricians, and here is another great video, this time by a guy called Sparky Ninja, and he's showing this situation occurring in the wild. I highly recommend you follow the link to that channel and search for Sparky Ninja, the video entitled Initial Verification, Testing Someone Else's Crap Work. Once you have completed the verification inspection of installation, it is almost time to start testing. Make sure your test equipment is working correctly by using a proven unit. These are quite expensive starting off, or using low voltage sources. This will tell you if your equipment is working correctly. Also, don't forget to null/zero your meter. This means that any cables that are included with your multifunction tester will have resistance in them. This includes the plug and socket adapters, grippers, and especially the use of a wonder lead. We want to take account of the resistance of that extra copper and then take it away. The same way we would zero a weighing scale with a removable bowl. How we do this depends on what multifunction tester you choose to buy and use. There are at least 5 or more reputable brands who produce multifunction testers. The process will be the same and they all have the same outcome, just different buttons to achieve this. I use a Mega X1 and will be using the brand as a basis for this video and in photos demonstrating examples in future videos. This is not a paid advertisement, it's just a brand I was trained to use and that's why I stuck with this. A wonder lead is a known length and cross section of copper wire/cable that you use basically as an extension lead to reach faraway places in an installation to test. An example of this would be you have your meter close to the distribution port and you need to reach the bonding conductor on the gas meter pipes, which is about 15 meters away, for example. Your regular leads are never going to reach. With a wonder lead, we can leave our meter in place and bring the longer lead to where we need to go, or vice versa, in order to conduct the test. If we forgot to zero our meter beforehand, we could get some very confused results. Trust me, this happens quite a bit. Here's an example of me zeroing a homemade wonder lead consisting of 2.5 squared stranded cable. I was using a Mega MIT 230 insulation resistance and continuity tester. This is not a full multifunction tester. It's a specialty piece of equipment. So picture 1, set the meter to ohm/continuity setting. Strip 2 ends of the wonder lead if using scrap cable and get a good connection on both ends of your crocodile clamps. This shows that the leads of the meter with the crocodile clamps and the wonder lead in picture 2 have a resistance of 0.07 ohms. In picture 3 and 4 on this particular test instrument and most Mega models, we press the test button once and the meter now shows 0 ohms. That is it, the test leads are nulled and the wonder lead is now zeroed with the test leads. They've been taken out of the equation. We can also see a circular symbol which reminds us that the instrument with these cables has been zeroed. It is important to remember that when we change any leads or any kind of wonder leads, we zero our instrument for most accurate results. This is demonstrated again using my multifunction tester X1, but this time without a wonder lead. All I am zeroing is my test leads. Set the meter to continuity, Clamp the two leads together and it will register a resistance. Press the test button and the leads will automatically zero and lock there. Anytime you change your leads, it's good practice to do this step again. We're almost done with the really boring parts of testing. However, I want to give you all of the information you need, not just the basics. The information is hard to come by for new people entering the field, and most people expect you just to know this or to learn it as you go along, which can be daunting. So it'll help you feel much better after you know this stuff, which never really comes up in your apprenticeship. That is, what paperwork and forms are for what and why are they used when testing. It is important to note that these are not free. Safe Electric charge you for every cert, and you can buy them as individual forms or in booklets of a certain number. This means that you should print out example copies from Safe Electric website and do your initial work on these in case of mistakes. Then fill in the proper completed one on official documents. They will reject anything messy or incomplete or any mistake written forms. You can find every document to download and print here on the Safe Electric website. You should know that these forms are to familiarise yourself for training purposes only. You can only purchase these forms once you have completed the Safe Electric application process and become a rec. The test record sheet is probably the most common form you will buy from Safe Electric. It is used to record the results from any test you carry out. You'll send this to Safe Electric for both pre-connection and post-connection tests. These will be explained in the next video, what these are and how to do them. Cert 1, probably the most used certificate for new domestic dwellings. It is used for normal sized dwellings with a maximum MIC or maximum import capacity of less than 50 kilovolt amps. As this channel is focused on teaching apprentices, we will not skip this opportunity to tell you about kVA. This is nothing to worry about and it just stands for kilovolt amps. These units are used to measure businesses rather than domestic homes, which use the simpler kilowatts as a unit of energy usage. This is because domestic residences are not charged on their power factor. To convert kVA to kilowatts, we simply multiply the number of kVA by the power factor. In this example of 50 kilovolt amps, multiplied by an example power factor of 0.95 would give us 47.5 kilowatts of actual useful power, or minus 2.5 kVA, or in other words, the wasted energy from the 50 kilovolt amps put in originally. Power factor and the theory of it will be explained on my channel in a playlist for Phase 4 apprentices. The Cert 1 is for when you are wiring a new house, for example, before the ESB have connected the power to the property. We would fill in a Cert 1 with a test record sheet for all of the pre-connection tests and send it to Safe Electric. Safe Electric will now review the results of your tests, and if they are happy, they will send this on to the ESB or DSO, saying that it's okay to connect the system to the grid. Once they have done this, you will be notified, and then you will return to the site to complete this form again with post-connection tests and the test results on a test record sheet. This certificate of completion is also used for any case in an installation of under 50 kilovolt amps, which most domestic dwellings are, if, for example, any changes are made to a property that require disconnection from the grid, for example, such as a board change without a double pole isolator or change of the meter tails. It is important to note that the original copy of this document is always given to the customer owner of the installation, and the coloured copy is the one that is sent to Safe Electric for verification. We also should keep a copy for our own records. It is important to note that this form in Cert 2 can be done online, but the system is pretty confusing and old. Cert 2. This is exactly as explained previously for the Cert 1, but for larger installations such as big commercial buildings or larger domestic dwellings or manor houses. Any installation equal or more than 50 kilovolt amps must use certificate number 2. The process is also the same for filling in this form. It is very important to note that a REC or registered electrical contractor cannot certify or sign off work that is not completed by yourself as the contractor and ask for a Cert 1 or 2. You can do an EICR or PIR but not certify the installation. Only with special permission from Safe Electric can this be completed, or in other circumstances such as a completed and paid for change in electrical contractor form for reasons such as bankruptcy. Certificate number 3 is a little different and is required for the completion of additional circuits added. Other add-ons and extensions, for example. It does not require connection from the DSO, the designated service operator, which is the ESB in our case. It is for jobs that can be de-energized locally. This is important to note because this form cannot be used to request connection to the grid from a DSO. Anything of this nature you'll have to refer to Cert 1 or Cert 2. Cert 3 is the same as previous two, insofar as you are required to complete the test record sheet for the work completed and send it in with the certificate number 3 completed. As mentioned previously, you are not required to file any documentation with Safe Electric for minor works. However, if the customer asks for it, you need to provide it. This is the document you would give to them for that work completed. There are other certification documents such as agricultural ones and temporary emergency ones. However, they are not used very often by the standard Sparky, and so we won't go into detail about them here today. PIR, or Periodic Inspection Report, commonly known as EICR in England, Electrical Installation Condition Report. These are not certification documents. This is several pages that ask multiple questions, which one answer will allow you to see the condition of an installation. We rate our findings in a number system from 1 to 4. They are requires urgent attention, is dangerous and should be rectified there and then if possible. Possible issuance of a notice of potential hazard. 2. Requires improvement. 3. Requires some attention. 4. Does not comply with current rules. This does not mean unsafe necessarily, just acknowledging this for the future, as it may have been installed in the distant past and functions just fine. PIRs are recommended to be carried out every number of years depending on where the installation is. For example, domestic houses, it is recommended for a PIR to be carried out every 5 years, a visual inspection every year, and to check the RCD test button at least every 6 months. To complete the PIR, you'll also need to do a test record sheet and record all the findings of the installation and give the originals of these to the customer. It is strongly suggested that when an installation is over 15 years old, that you recommend to the customer that EICR is completed. They will sometimes not agree to this as it can add quite an amount to their bill, and you should consider their wishes before proceeding. It should be noted in the comments section that this was recommended to the customer on the test record sheet of any work to be completed. This is because once you start any major work on a board, you have taken cognizance of the installation in its entirety, in the words of Safe Electric. This means that you are now responsible for it and must carry out several tests on it to ensure that it is safe. Here is a link for the tests which must be carried out. In good news, you can earn as much as €1,000 doing one of these, depending on your rates and the size of the installation. It's not bad, and it's about incentives and not just boring paperwork. You'll be rewarded for your hard work and your knowledge. An NOHZ, or Notice of Potential Hazard, is a form where a registered electrical contractor discovers a potentially hazardous situation with an installation. If he or she is not in a position to rectify it, or the customer does not want it remedied in that scenario, the REC must issue a notice of potential hazard. This document is straightforward to fill in, such as violations of the rules. It comes in 3 parts. Issue the original white copy to the owner of the installation. Send a yellow duplicate copy to Safe Electric, preferably by express post depending on the severity of the hazard, and the REC keeps the blue copy for his or her records. The rest will be dealt with by Safe Electric. Just make sure to keep your records safe, and it can be no harm to take pictures also, though this is not required. A picture says 1,000 words, and it can keep you out of trouble someday. It's also worth noting that the REC should probably keep some of these forms handy in the van in case this situation arises, because buying paper documents and waiting for them to be delivered by post by the ESSB, or the Electrical Safety Supervisory Body, which is Safe Electric in our case, can take some time, and sometimes they don't even have them in stock, which can leave you in a bad predicament. So hopefully everything will be online in the near future. And that's that. In the next videos we will go through each of the tests we are required to do and explain them easily and using diagrams. So cheers and see you on the next one.